and welcome to the Emerging Hygienist Group. The Emerging Hygienist Group is the space for hygienists to network, knowledge share, and explore the pathways to becoming a certified occupational hygienist.
Members of the EHG will be able to attend events aimed at assisting participants in obtaining the skills, support, and knowledge to successfully advance their careers, develop a network, and identify career opportunities.
We encourage AOH student, associate, provisional members, and anyone interested in a career in occupational hygiene to join.
To become a member of the EHG, you can request access through LinkedIn via the link on the AIOH website or by contacting admin@aioh.org.au. We look forward to networking and collaborating with you all very soon.
So thank you to everyone who has joined today. We've got a very exciting talk from Mark Reggers. So Mark is I'm going to have to look this up because it's a long title, the Specialist Application Engineer for the 3M Personal Safety Division, as well as a Certified Occupational Hygienist and the AOH ResFit Chair. So, a lot of people have probably bumped into Mark at the conference or crossed paths along your career. And as we all know, Mark is a specialist in respiratory protection and anything PPE. So it's a really exciting opportunity for us to be able to kind of ask some questions around personal protective equipment. And I think with a lot of things going on in the hygiene profession at the moment regarding welding fume and silica, it's really important to kind of understand how our PPE is working, how to select it, and if there's any questions around different things with PAPRs and potentially testing effectiveness and whatnot.
Do you just want to mute everyone if you can?
Yeah, I was just going to jump in and do that. I think we're good. So just a quick one as well, an announcement for the EHG before we jump in with Mark. So the EHG has been going now for about 2.5 years. It's been a long process, kind of getting it set up and getting our name out there. And we've finally got some progress. We're about 450 members now, which is very exciting. We've kind of been running about four different Ask Me Anything events each year and different networking events. So the original intention for the EHG was for it to be a leadership role for one person within the AOH community every year. So as of next week, I'm going to put out an expression of interest for anyone who would like to take over my role. And that'll be a yearly changeover to have a lead for the committee. So currently there's 5 of us in a working group, a few are on the line. We've got Claire and Hamish. We also have John Padgam and Ben Govan. So they're all committed to staying on in the working group as well as myself, but we'll just need a new face and organiser. So it's a really great opportunity for anyone who wants to step up, make it your own. And it's a really great way to connect with with the hygiene community. I've been fortunate enough to kind of meet everyone like Mark and a lot of the other leaders in the industry. So I'll put that out next week. And if anyone wants to reach out for more details around what it will entail, just let me know. But let's kick it off. Mark, over to you.
Oh, no worries. I'll say I'm very jealous that this group exists. Starting out not too many years ago now, but just would have, absolutely to be able to network like this. I'm very jealous, but I think it's an amazing thing doing so. And putting your hand up for these kind of roles are very daunting on one hand, but they are so rewarding with the networking professionally as well. So certainly, if I can help add to the plug there from Lucy, is well worth it. I know when ResFit was kicking off, it scared the pants and the life out of me kind of thinking, but you get a lot out of it. So certainly can recommend that as well. So my official title in the 3M world of thing is an application engineer. So many of you may deal with the 3M, our sales guys or girls across the countryside. So I sit in a team that is part of the technical team, application engineers in the 3M world. So across all the 3M business groups, post-it notes and command hooks in the different divisions, there's equivalent application engineers that are the sort of the technical point of contact around products for the sales team as well. So in our team, in the personal safety division, there's myself, and I sort of look after and focus on the respiratory protection side of things, from disposable, reusable, PAPR and the welding portfolio. Some of you may know Julie Tedeschi, another hygienist, and she based in Sydney. She looks after the hearing and communication portfolio. We also have another hygienist in New Zealand who covers all the New Zealand area. And we've got another gentleman for fall protection and another person who's the head eye face side of things. So that's kind of a little bit where my role in the 3M sits from a technical point of view. And obviously, a large part of that is being able to do training and education on respiratory protection as well. One of the other roles I took on towards the end of last year is also now the chair of the Australian Standards Committee as well. So if you've got any questions re standards or anything like that, I'm certainly a place to start with, as well as Jane Whitelaw and Terry and many others with those respirator questions come up. Look, this is a very general 3M thing. Obviously, we're talking general stuff in nature. Obviously, I use this same sort of slide when doing stuff for workplaces. Obviously, I need to take this information and apply it. But given the audience we're presenting to in the occupational hygiene world of things, that's what we do as a profession, and get specific and help out. So hopefully the information, we'll sort of cover today and at least sort of highlight we think would be of interest or value, sort of cover a couple of those things will help as well. So respiratory protection, and look, a lot of this stuff is probably, I certainly appreciate you probably across some of these things, but certainly good to reinforce that respiratory protection or respirators do not eliminate exposure. And I'm sure you've had workers that I've got this respirator on or hearing protection on, and it doesn't eliminate it. So when we think about respiratory protection, the concept is about reduction, reduction of exposure from a hazardous level to a acceptable level, which is where we use our workplace exposure standards or limits, soon to be called, as we know, in the future. So when we get into the protection factor side of things, we're always going to be thinking about reduction, and appropriately selected respirator is going to reduce those exposures very, very low to pretty close to being eliminated in some circumstances, but it is not an automatic zero thing. Respiratory protection, as far as thinking about airborne hazards, and these are things that we're all very familiar with in our world of things, but certainly when talking to workers or I'm doing training with, different within our 3M team or some of our distributed team, is, first question, what is the hazard? What is the airborne hazard? The start of we need protection from whatever that may be. And particulates, when we think about, dust, mist, fume, fibers, all these different terms, they are all in the family of particulates. And so one of the things we'll cover today is just sort of the basis of how particulate filters actually work. And certainly talking to the different workplaces, why is it it's a P2 for welding fume, and then a P2 in hospitals for COVID, and then it's a P2 for diesel particulate matter, all these different hazards, but it all is, the same type of filtration rating. And so this is one of the good things with particulate filters when we get into it, is that, the capture mechanism is based around the size of the particulate. So obviously breathing the different particulates in will have different health effects and consequences in that regard, but from a capture point of view, they all get captured in the same type of mechanisms. Our other airborne category is our gases and vapors, which similar as we know, but obviously a vapor is evaporating off a solid or a liquid, but still from a capture point of view, going to be a gas vapor cartridge. And then we've got our oxygen deficient environments, commonly associated with confined spaces or other types of thing. So this is where I'm, if I'm talking to workplaces or workers, first question is, what is your hazard? What are you coming up against? And that's obviously going to point us down a direction from a respiratory protection point of view, where we may go. And certainly if it's an oxygen deficient environment, well, we're going to have a certain type of supplied air respirators. So sort of that first thing, respiratory protection, what is the thing we're needing protection from? So
Mark, sorry, I'm just interrupting. I was just checking if you had slides that were supposed to be up now, or were they?
Yeah.
Can everyone see them? I can't see.
Yeah,
slides.
I can see
I can see them.
Oh, I can't. It might just be my view. Okay, sorry to interrupt.
You can see why she's wanting to step down. She can't even look at us. No, sorry. Good to check. I mean, I've got a screen sharing thing on the on the top there. So
yeah, okay. No, it's good. I've got it now. That was my user error. Continue. Sorry, Mark.
Good. Safer to check. So the next little bit, is thinking about, we're going to cover off how do particulate filters work from a fairly high level point of view, and how do gas vapor cartridges work. And it's something that I've always found interesting since I've been in the PPE industry, and certainly explaining to workers, how they work also helps highlight, the limitations around respiratory protection as well. So this is a little video. We did check the sound before, so hopefully that'll still work for us. But this is a video. It's not a 3M video, but it was a video that was a YouTube channel, Minute Physics, put out in the fairly early days of the pandemic. Explaining, the physics, like how do N95s work, or why do they work so well, thinking about all the conversation around face coverings or a handkerchief or other kind of things. Why is it that it's recommended from the government departments and safety people of an N95? So hopefully you'll find this interesting. Something you may not have thought about before or needed to think about, but certainly give you an appreciation of the science that sort of is built into all these types of products. So hopefully you can hear the sound here.
Prior to March 2020, there's a good chance you didn't know what an N95 mask was, or at least didn't think about them unless you were doing a home repair project with lots of dust, or live in a part of the world with crazy pollution or wildfire smoke. And upon learning about them, you might think, like I did, that an N95 mask is basically a really, really fine strainer, a mesh of fibers with gaps too small for dust and other airborne particles to get through. A strainer filters out particles larger than its openings, but not particles smaller than its openings. So you'd expect that with a mask, after a certain point, small enough particles will sneak through. But this isn't how N95 masks work. The particles they filter are generally much smaller than the gaps between the fibers in the mask. What's more, an N95 mask is actually really good at filtering both the largest and smallest small particles. It's medium-sized small particles that are hardest for it to block. This isn't at all like a strainer, because N95s are much cleverer than strainers. The overarching goal of an N95 mask is instead to get an airborne particle to touch a fiber in the mask. Regardless of how big an airborne particle is, once it touches a fiber, it stays stuck to it and doesn't become airborne again. This isn't anything special about the fibers, but about the size of the particles. At a microscopic scale, everything is sticky, because the weakly attractive force between molecules is more than strong enough to hold very, very small things in place. So you shouldn't think of N95 masks like a fine window screen that keeps insects of a certain size out. You should think of them more like a sticky spider web that can catch an insect of any size, as long as it touches a strand. And so N95 masks use a bunch of different clever physics and mechanical tricks to get particles to touch their fibers. First, many spider webs are better than one. Unlike strainers, where stacking many identical ones doesn't improve the filtering at all, more layers of sticky fibers means more chances for particles to get stuck. And how likely particles are to hit or miss a fiber depends in large part on their size. Airborne particles larger than 1/1000 of a millimeter basically travel in straight lines because of their inertia. And because there are so many layers of fibers, their straight line paths are essentially guaranteed to hit a fiber and stick. Airborne particles that are really, really small are so light that collisions with air molecules literally bounce them around, so they move in a random zigzag pattern known as Brownian motion. This zigzagging also makes it super likely that a particle will bump into a fiber and get stuck. Particles of in-between sizes are the hardest to filter. That's because they don't travel in straight lines, and they also don't bounce around randomly. Instead, they're carried along with the air as it flows around fibers, meaning they're likely to get carried past fibers and sneak through even a mask with many layers. But N95 masks have a final trick up their sleeve. They can attract particles of all sizes to them using an electric field. In the presence of an electric field, even neutral particles develop an internal electrical imbalance which attracts them to the source of the field. This is why neutrally charged styrofoam sticks to a cat whose fur has been charged with static electricity. But unlike a cat's fur, an N95 mask's electric field isn't just ordinary static electricity. The fibers are like permanent magnets, but for electricity, electrets. Just like you can permanently magnetize a piece of iron by putting it in a strong enough magnetic field, you can electritize a piece of plastic to give it a permanent electric field. By electritizing the fibers in an N95 mask, they gain a long-lasting ability to attract particles, which means they capture about 10 times as many particles as regular fibers. And this is, after all, the point of an N95 mask, to filter out particles from the air, and they do it cleverly. By taking advantage of the molecular scale stickiness of matter, using many layers of fibers that catch straight-moving large particles as well as zigzagging small particles, and having an electric field that attracts all particles, you get a mask, not a strainer, that's really good at trapping both large and small airborne particles, and does a reasonably good job at filtering out middle-sized airborne particles. Precisely what fraction of those sneaky medium-sized particles get blocked gives you the number of the mask. If at least 95% of those particles are filtered out, then the mask is rated N95.
So it's a common question. I've been asked many times. I don't know our team would, you know, from a workplace, or maybe you've had it as, you know, what's the smallest size particle that the respirators that we're using will actually capture? And so it's kind of not quite the right question, as opposed to what is the hardest particle size to capture, which is in that specific size range, which can either align with the air currents and bypass and not get captured. So here's a couple of, I guess, visuals adding on to that animation. It's such a simple little video, but it really does a really good job of explaining, you know, how these particulate filters work and why they are so effective. And when we think about, you know, why is it that it's a P2 for welding fume? Why is it a P2 for, you know, bioaerosols? Why is it P2 for all these things? Because it still comes down to the size of the particulate or whatever it is. So I know from a, you know, filter point of view, if I get sent an SDS, or maybe you're getting asked to make some recommendations, like if it's a powder or a particulate, there's a, you know, a particulate filter is going to work irrespective of what it is made of, if you know what I mean, in that regard. Obviously, if it's going to have, you know, vapors coming off of thinking about paint spray, we need to be thinking about, you know, organic carbon or cartridges as well. But you can kind of see here with the different particle sizes. Let me get my laser pointer here. You can kind of see with the different sizes. So you think about one micron, and you think about, you know, respirable coal dust, respirable crystalline silica, welding fume. You know, obviously a percentage of that is still going to be bigger than one micron, as well. Thinking about a dust cloud is going to have a range of particle sizes, where the vast majority are going to be getting caught very, very effectively. With that combined efficiency with the different capture mechanisms gives us this most penetrating particle size. So this next picture here is a magnified view, a little project I did a number of years ago to kind of get some hopefully interesting visuals for different training presentations. So that's one layer of what was now 2128, so it was a P2 filter. So you kind of get this visual, and I like to explain like a sticky bowl of spaghetti, where we think about that particulate zigzagging its way through to, if you know, would need to zigzag its way through all this depth of fibers. So when we think about particulate filters, it's defense by depth. So if you have a look at that little animation, hopefully it's coming up clear for you, where some's going to be getting up on the upper parts of the fiber body or the fiber layer, and as you get further down, some are going to make its way through there as well. So it's got quite a tortuous path to zigzag through. So this is what we call a non-woven type of material in that regard. And you got to think there's multiple layers of different fiber sizes. We'll look at graduated density in a second. So as we get into the particulate filter ratings, and I'm sure you're all familiar with P1 and P2 and P3, all three of these filtration or these ratings are all tested against the same particle size, which is that most penetrating particle size, that, you know, 0.3 to 0.6 of a micron. So they all get tested against the same particle size, you know, worst case scenario, but it is the amount of that challenge agent it needs to capture or stop to determine what it's rated. So a P1 to a P2 to a P3 all use the same capture mechanisms, but as you can appreciate, you know, generally it's going to be the depth of the filter bed is going to be thicker to achieve that higher filtration, because we've got a longer pathway for that particle, aerosol, whatever, to work its way through. And that's where it sort of comes to the skill of the manufacturer, where there's lots of products out there that, you know, meet a P2 or a P1 with certain products. And I'm not on the sales side of things, but probably most of you are familiar with the 3M Aura style of product. This has a really high use of electrostatic attraction to achieve its efficiency. So that's where you're able to get thinner filter materials while still performing, or, you know, filtration at these levels. So obviously lower, you know, thinner fiber beds, less breathing resistance, you know, more comfort, a bit more comfort to the wearer comparatively. So I know I used to think about, you know, P1, that's pretty crap. It's letting in 20% of dust. But when you think about, well, that's got to stop 80% of the hardest particle size to capture, where it's, you know, recommended for mechanically generated particles, drilling, grinding, sanding. The size of those particulates are big, massive, whopping boulder type of particles compared to the test size of that most penetrating particle size. So we think about common general industry exposures, the vast majority are going to be over that 1 micron size. So that P1, when appropriately selected, is going to be filtering at that 99.999 type percent of those big chunky particles as well. So get an appreciation, it's the same capture mechanism, that's happening, but generally it's that fiber bed with the difference. With PAPR particulate filters, there is a different efficiency level. So PAPR P2 is greater than 99% efficient versus a negative pressure respirator in that regard. So, but typically when people are talking P1 and P2, most people are thinking about those numbers and the negative pressure type of air purifying respirators. The last couple of years, I've also been covering the US rating system, given the pandemic, and a lot of the general population know what an N95 is. And as that alluded to in that video, those numbers, 95 or 99 refer to that percentage that it needs to stop. In the US, they have three particulate rating series, as you can see, N, R, and P, where the R and P is considering about oily particulates. So what happens with oily particulates is it will coat those fibers and it'll reduce that electrostatic capture mechanism. So generally your R and your P filters, looking at the US range, I think some of our consumer division have a couple. We've got one or two of our disposables that aren't just the N series, but generally they're going to be thicker again with a high reliance on those physical, crashing kind of thing as opposed to electrostatic capture kind of thing. So when we line up a P1 to what's in the US, they don't have a P1 equivalent, P2 to N95. We don't have an N99 equivalent. P3 is sort of close to the N99. With, ours being 94%, theirs being 95%, they have a 10 litres per minute higher flow rate. So obviously that adds another challenge with a faster or a higher flow rate. So that's why they're kind of equivalent. We've got a tech bulletin that sort of looked at these other different international ratings and aligned up sort of the things as people across the globe were sourcing respirators from wherever they could during those times. Another little thing that is in these particulate filters is what we call graduated density. So this is a little display stand in our innovation center that I use to we talk about non-woven technologies. So on the left-hand side is what typically we're going to get with our filtration, where we want the upper layers of the fiber bed to be wider open to allow the smaller ones to pass, knowing they're going to get captured deeper in the fiber bed. Versus if we were to make everything, from a thin fiber point of view or gap between them, that's going to filter very well, but clearly, as you can see visually, they're all going to get caught on the top part of the fiber, which is not a bad thing. But from a breathability user point of view in respiratory protection filters, that's a big thing. I mean, the depth of the fiber bed doesn't really make much difference because everything's getting caught on the top. So this is where, say something like, we're in our, say 3M range, we've got a whole range of different disposable respirators. Here we've got an 8822 respirator, that's a P2. And here we have, this is an 8214 equivalent N95. So this is a welding disposable respirator, where hopefully you can kind of see, well, this is what we call has a higher loft type of filter material. And some of our marketing gear materials will talk about, clog resistant. What they're referring to is this higher loft, depth for the fibers, or not the fibers, to the welding fume and a welding intended product to get caught, within that. So less breathing resistance as it builds up or starts at a lower breathing resistance. So if I play this little video here, hopefully this will work for me as well. So you can kind of see as those ball bearings filter down. I'm sure most of you are familiar with one of our reusable. We've got a 5925 pad or a 5935, where we'll have instructions on there to have it a certain way, and that's to do with the more open top side is the one we want to the air, and the other side to the wearer. So if you ever have one of these in your side, if you want to have a look at them, the bottom side is going to be that thinner fiber. So if you put it in the wrong way, it doesn't mean you're not going to be getting protected, but all more stuff is going to be getting collected and on the top of the fiber, still protecting the wearer, but from a breathing point of view, is going to get clogged up, as opposed to how it's designed, which is similar with the secure click filters, where we have instructions on which way to have it up for that reason. Another couple of hopefully you find interesting pictures from looking at a non-rated pre-filter, where many products and many manufacturers will have a more coarse pre-filter to sit on top of the main body filter, and as you can see, it's the same magnification, but you can clearly see the size of the fibers and the size of the particulates that is capturing very different. So this is a PAPR Jupiter filter cut out, or did back in 2019. So clearly you can see the size of the fibers and the size of the particulates are very different. So the pre-filter is doing its job and the main body filter is doing its job. So not having a pre-filter is still going to protect the wearer, but certainly likely to clog up a bit quicker because it's going to be capturing all of those larger ones as well. A common question I'm sure you all have been asked, how long will my particulate filter last? You know, that really does depend on the situation it's being used in. You know, particulate filters are great in the fact that the more they clog up, the more they capture, they become a better filter. Because you think about our sticky bowl of spaghetti, it's going to get harder and harder for a particulate to get its way through as it gets clogged up and more gets, you know, on the top of those fibers as well. So that's why there's that general rule of thumb around, you know, unacceptable breathing resistance to airflow. But when that happens, well, what are you doing? How long are you doing it for? What's your exposure levels? All those types of things. But at some point, you know, there'll be that unacceptable resistance to breathing airflow. On disposable respirators, the same concept applies, but often, you know, you've probably seen the sites you've been at that these things will get disposed of more because they're dirty and sweaty than, you know, the filter's getting that clogged up. You know, so it doesn't mean the filter's not working, but other reasons why the product may be getting changed. There are shelf life dates for these types of products as well. Not that they're going to stop working after that date, but as a manufacturer, certainly, you know, these are rated and claimed and marked at a certain performance level. So certainly over time, depending on how they're stored, well or not well, you know, the surety of it performing at a certain level isn't necessarily going to be there, or 3M can't guarantee that. I'm conscious of the time because we started a bit later, but I know during the pandemic, was it NIOSH? They did some filtration testing and a whole bunch of their pandemic stock that had been expired by 11 years. So, you know, well and truly past the shelf life and the manufacture date. And on a filtration point of view, the products were still filtering. The vast majority, 99 whatever percent, were filtering greater than what the, you know, obviously they were rated for. You know, obviously that inherent filtration protection is built into that physical structure, as you could imagine. And they weren't checking the head straps and what the condition of the nose foam was, or, you know, thinking about the adhesive. So thinking about a respirator being rating as a combination of a product, and it's more than just the filtration, you know, that's going on. But yeah, I've got a few other stories, but I'll keep going for the sake of time. Then we move into the gas vapor world of things and the type of capture mechanism, which is very different to the particulate filter. And this is where we're using activated carbon, charcoal, and it's, you know, simply about the surface area of that carbon, so the macropores and the micropores. Depending on the gas and the type of treatment, it's either going to be a chemi absorption or a physi absorption. But think of it surface area, that surface area, when you sort of lay it all out, thinking about all the structure, as you can see there, that's what's giving it the performance and the capacity and the amount of carbon that's in there. I'm sure you're familiar, once again, with these types of you know, colours. These are the colours out of the Australian standard. So, you know, any manufacturer that's making it to that standard, you'll see the same colours that are there as well. The thing I typically really highlight for workplaces and thinking about respiratory selection, you know, where particulates, doesn't matter the type of particulate, it's that physical capture. But once we get into the gas vapor side of things, there's not a gas vapor cartridge, you know, for every type of gas or vapor that's could be in a workplace in that regard. So knowing what that contaminant is critical, is absolutely needed to make a confident recommendation to what a, you know, worker is being exposed to or potentially going to be working with. And this is where, you know, between manufacturers, so your A, B, E are consistent across the standard. They have the same test gases. The actual carbon mix, you know, between manufacturers will be different, you know, as much as it meets that base level of performance. Like we have a 6096 cartridge that we know has performance for phosphine. You know, we've tested it. So if someone rings me up and asks for phosphine, we didn't have a phosphine class in our standard, but I know as a manufacturer, we know it has performance and we provide that information. And that'll go for, you know, all of the, you know, respectable manufacturers, you know, thinking about where their products and the typical type of industries as well. So that's why you kind of can't compare, you know, a 3M filter recommendation on, you know, this product is exactly the same as a Draeger one or a Honeywell one, whatever it may be, because they're both an ABEC. So that carbon can be a mixture of things and the quality of carbon as well. Then you'll see, familiar with the A1 or B2 or, different classes. So what that number is referring to is the capacity of that specific product, or it's met the minimal benchmark of those different levels. The way I kind of, trying to simplify the analogy is using buckets where, an A1 and an A2 are both going to capture the same contaminant, but obviously with a bigger bucket or more capacity, the point at which that filter is full is going to be different because we've got more capacity, if that makes sense. With a breathing resistance for the gas vapor components, there is, the breathing resistance doesn't change from a brand new out of the packet product to fully full, and breakthrough is starting to occur. So that's where that 1, 2, 3. So bigger bucket, smaller bucket. How long will my cartridge last? Well, are we trying to fill that bucket with a water hose, or are we filling that water bucket up with an eyedropper? At some point it's going to be full, but obviously how much and how quick that's filling will depend on that time. So that's similar. What are you doing? How long are you doing it for? Also with organic vapor cartridges, the relative humidity that water vapor takes up part of that surface area on the organic carbon. Where in the acid ones, where we've got the chemi absorption, it actually helps with the bonding process. So there's kind of a two-edge kind of impact depending on where you are. So if you're in a high relative humidity environment, in a low relative humidity environment, it's still going to capture the contaminant, but the point at which that will be full will be different because, the high humidity, that water vapor is going to be taking up part of that surface area. Something our current standard has, we'll talk about changing a gas vapor cartridge at an absolute maximum 6 months after opening, at an absolute maximum, just trying to communicate that these things don't last forever. And once again, I'm sure you've been into workplaces, if you're consulting, or maybe your own places, if you're a site hygienist, where they got their respirator and their cartridges sitting on a bench. And it's like, well, how long has that been there for? Well, I don't know. Has it been used? Well, I don't know. So having confidence, because once the cartridge is full, that's when breakthrough occurs. And like I said, I've got lots more other presentations that goes into a bit more detail about, what's going on in the carbon. But once that's full, that gas or vapor is going to be passing through it once all that surface area is taken up. I'm going to be presenting, I got the email the other day, doing a 4-hour basic protection CES at the Hygiene conference. So that one I know will definitely go into a bit more deeper about using the car park analogy and low boiling point organics and the volatility and the concerns of those kind of things as well. But like I said, just trying to set the scene with a couple of these considerations as well. And I'm hoping that you all know that we are not relying on odor or taste or irritation as a primary indicator of when to change our cartridge, because we know workers, I'll just change it when I can smell and taste it. No. Certainly, we know different chemicals have different odor thresholds, and the point that you could actually smell it, relative to the exposure standard. By the time you're smelling it, could already be over the exposure standard or at a hazardous level. Think about, H2S, those that cause olfactory fatigue. So your sense of smell is going to be reduced, let alone ones that don't have smell as well. So 1715 at 4.2.5.3 has a whole page. Sorry, not on, I haven't listed there, but in 1715 there's a whole page on, the reasons why that we as humans are terrible indicators, and we don't want to be relying on that worker individual saying, yes, no, I can taste this. So this here is a free tool, as you can see from the web link there, for anyone, anywhere. It's a global 3M tool where we have one part of is if you're dealing with a chemical benzene or xylene or whatever it may be, H2S, you can put it in and it's going to say, hey, here's a range of cartridges that are suitable for that contaminant. And the other part of the platform is the service life software, where it is going to give you an estimation of breakthrough. Being in the hygiene world of things, more often we're going to be the people collecting those numbers or have those numbers or providing those numbers to workplaces. We can go in and for a pretty wide range of chemicals, and most of our products can enter in the detail. So here's an example. I put in 5 ppm benzene. And we're using this particular product here at 6055, and put in the variables for 65, less than 65 RH, temperature, work rate. And this is for the reusable respirator range and also the PAPR range. So instead of putting your work rate, you would put the flow rate or the fan rate of the PAPA unit, so TR 600, 800 in our range of things. You can then generate a PDF. So if as a site hygienist, you can put print these out and put that in your RPP as part of that evidence to support your filter change schedule, whatever that may be. And then thinking about, we get an estimate, but certainly, it's got to come back to the wearers and the workers, what's going to be easy to remember, thinking that it is just an estimate. I mean, different people, different work rates, but certainly we want to have some capacity left in the tank, so to speak, to change it before that breakthrough occurs as well. Certainly for certain, gases, acetone, that one is one that comes up a bit in the fact that it's in a lot of solvents. It has a pretty low odor threshold compared to the exposure standard. So depending, where you may be able to once or twice, have it where we sort of track when the smell breakthrough may have occurred, knowing what it is and what that level is going to be. And then maybe that changes breakthrough after 3 weeks or after a month or 2 months, whatever the situation is. And then putting a buffer in that to say, all right, let's change it every 2 months or something before that as well. So just trying to inform some bit of data when knowing what those exposure levels are. Something that 3M used to do many, many years ago before my time. So let's say that you've got a cartridge that on site, that they've been using, right, we've been using this for 2 weeks. How much capacity is left in this product or this filter that I'm using? So Assay Technologies is a US company where you can obviously get in contact with them. This is not a 3M company thing, but certainly in the roles that we or you guys might be playing or maybe suggesting, certainly, we've got a range of chemicals and very set test environments, but let's say you're trying to replicate an environment. One hygienist, and they were talking about hydrogen cyanide, and they wanted 90% relative humidity. So if needed, you could go and simulate that test environment. So if I go back to the analogy also of if you've been using it for 2 weeks, well, then you can send that over with a brand new one. And then you can see, well, actually, compared to nothing being used, we've got, we're only using 20% or 50%, whatever it may be. And that can support, the change of pushing out your filter change potentially. So instead of changing your cartridge, every 2 weeks, maybe it can be every month. And if you've got a lot of workers that are changing it 2 weekly, that certainly is a cost justification or business case to help save some money by using these kind of things. So certainly there's a cost to do that, but certainly I think if that's your situation, that you may be able to support that or show that pushing it out is still going to be acceptable. There's those kind of things that are out there. I call this the family tree of respiratory protection, and I'm sure you're familiar with these. You've used probably most of these in your own travels or training as well. Key thing I'll just sort of highlight, we've got the air purifying side of the family tree and our supplied air. Air purifying are those types of products which use a filter or a cartridge to capture the contaminant as the air is passing through it, and the wearer is on the other side of the filter and breathing that filtered air. Negative pressure and positive pressure. I know from a ResFit exam point of view, we certainly have questions. If anyone that's planning to go for it or has gone for ResFit, base understanding what is an air purifying respirator. Air purifying respirators don't provide oxygen. So we get a lot of people, that may be newish into this space or respiratory protection, outside of standard disposable, and they'll put down a PAPR as a supplied air respirator because it's blowing air, but it's still using a filter in the blower to capture that out. So that sort of come across that a little bit versus our supplied air side of the family tree is that we're providing air to the wearer, external or independent of the immediate work environment that they're in, whether that's from an SCBA, cylinder, or from a compressed air line through an air panel, or maybe from some cylinders or escape sets. So air purifying, we got to know what the contaminant is. If we're in an environment that's ideal H, oxygen deficient, unknown, hey, we're going to make sure we're bringing air to the worker as opposed to relying on filtering and capturing the contaminant out of the air. Now, something Lucy had highlighted and wanted me to touch on, given I do work for 3M, is sort of the difference between VersaFlow and AdFlow side of things as well. So quickly and hopefully simply that, yes, all of these products are 3M products. All of them are PAPRs, powered air purifying respirators. The AdFlow units, and you're probably familiar with the Speed Glass welding series range of head tops that can connect to the AdFlow, was made by a company that 3M acquired many years ago now. So it was a system that was brought into the 3M world of things, which really was intended for, heavy duty Boilermaker, that type of welding type environments. 3M had other pappers, and through the time and elevation and evolution on ranges, then now we have the VersaFlow range of products, which is the 300, 600, and 800. So any of the Speed Glass head tops are compatible with the AdFlow. Some of the Speed Glass are compatible with the 600, 800, and none of them are rated to go on the TR300. In Australia, the AdFlow products are exclusively wholesaled through Apex Welding Safety to the market. They had the agreement with the company who 3M acquired way back in the day, and that's just continued on. For those that have dealt with AWS, they know their stuff. When we look at some of the welding fume stuff that we're all aware of, they're right on the front there trying to educate workplaces around controls as well. So each of the 300, 600, 800, or 600, 800 have the same type of filters, but 300, 600, 800 have a type, and then AdFlow have a different type as well. Due to our Australian standards with our multi-gas capacity requirements versus Europe, the AdFlow does not have an Australian standards product that meets a multi-gas A1, B1, E1. It meets the European requirements. So the AdFlow multi-gas is a nuisance level product for Australia because it doesn't meet our Australian standard. Versus on the 600, 800, we do have a A1, B1, E1 HGP3 cartridge. So certainly do talk to workplaces where they do have that need for multi-gas protection above the exposure standard. So like I said, that's a quick snapshot, but certainly if you're trying to work through what's what and what goes with what, please do reach out to myself or the 3M team that you deal with as well, because it is can get confusing if you're not sort of dealing with it regularly enough. But from a protection point of view, on a PAPR P2 or PAPR P3, all on a PAPR below with a loose fitting head top, Speed Glass, all going to be an assigned protection factor or RMPF of 50. The rest of the world, 3M sells the AdFlow and Speed Glass range as they do with the other kind of things. So we kind of have a little bit unique because of that historical agreement with AWS, but they've got some fantastic resources and papers and white papers around welding fume as well. So certainly don't hesitate to utilize their resources as well. Now we get into this term definition of protection factor. I'll use this first slide to explain protection factor, but given the wonderful audience that we have, I'm going to sort of talk about the other types of protection factors as well, depending on what you're trying to achieve and where it's actually being used. So simply, when we think about a protection factor, is the reduction of exposure from outside the respirator, so CO, concentration outside, to inside the respirator, concentration inside, so CO. So pretty simple, numbers here to get the concept across. So we've got 20 outside and 2's getting in through whatever pathway. We think about, reduction in exposure doesn't eliminate exposure. So that, whatever's getting in may be coming through the filter, maybe coming through the seal, maybe coming through an exhalation valve. If it's getting in, we're going to count that as going to be breathed in. So 20 divided by 2 gives us a 10-time reduction from outside the inside. And then now we get into then we talk about workplace protection factors, where that is the actual measurement of a worker on the job, outside, inside, what protection is being achieved in that regard. So typically, a workplace protection factor definitively is one that's being measured. So typically it's really used in studies or, trying to, determine, looking at more so done in probably the 90s when they're trying to establish, that respirators are effective. Then we have a simulated workplace protection factor. So when we start thinking about, confidence of large reductions in exposure, do we want to be putting workers in very high exposure environments and hoping that the respirator combination is going to be suitable? So this is where they'll use obviously simulated protection factors in a lab to correlate protection factors. Then we have an effective protection factor, which is the measure of the protection of the respirator as well as the wear time. So it's great if the respirator can provide, an assigned protection factor of 50, but if it's only being worn for 50% of the time, when the worker's out there, well, we're not going to be using a 50 times reduction. So that's what is the actual effective protection factor being achieved, thinking of the respirator and the wear time. In respiratory standards, you'll hear this term, what is the assigned protection factor? So that's where a respirator type or class has been assigned, given a protection factor, which is the anticipated level of respiratory protection. So we think about a disposable, half face that has, an assigned protector or RMPF of 10. That's the minimum expected number that all wearers should be able to achieve. So you look at, in some of my other presentations, I have some graphs just showing, the actual workplace protection factor being achieved from a half face reusable on a product that's given a number 10, but you're getting people with 100 or 1,000 times reduction. But when you look at, the cohort, we want to pick a number that, 95, 98%, all people, nearly all, are able to achieve, not knowing which worker is achieving just over 10 or the worker is achieving 100 or 1,000 times reduction as well. So certainly there are those safety factors built into it, trying to think of all workers and all work environments and work rates. And those numbers are based on the wearers doing the right thing as far as clean shaven, fit tested, and knowing what they're doing in that regard. Then our Australian standards use this term called required minimum protection factor. So similar in that when you're calculating what class of respirator may be needed based on the exposure level and the amount of reduction required. So I think that my next slide up will probably help visually show this, but what is the minimum amount of reduction? So if we're 10 times over the exposure standard, at an absolute minimum, we need a 10 times reduction to get us down to 10, or maybe we're 30 times over the exposure standard, so we need at least a 30 times reduction. So we're sort of saying that's what the RMPF uses, and the standards talks about, these products are suitable for an RMPF up to 10. So it's kind of the same, you're assigning that class of respirator 10 or 50 or 100, whatever it may be. And not to try and confuse things even more, but in the new ISO world of things, which over the next 5 years you'll start to see and hear a lot more about, the new ISO suite of standards have another different terminology called protection level, which is similar, but it'll be given to a combination of a product based on its individual testing performance, as opposed to, all half-face disposables, no matter who it's from, is going to be given a 10. So, but this is sort of the visual poster that we put together, and happy to share posters with these kind of things, trying to help explain, this concept. And so this concept applies to any type of contaminant, because we're using the exposure standard as, what is that acceptable level? We want to get it down and underneath too. So, 5 times the exposure standard, we're going to need something that has at least 5, which is going to be, anything above it to bring us that reduction down to our WES or well. So even if we're 30 times over, even if we were to use something 10 from our, calculations or our very base numbers we're using, a 10 times reduction is going to give us a reduction, but it's not going to be sufficient to bring us down to where it needs to go based on the contaminant that we're trying to protect our workers from. And ideally, we want to get well beneath that exposure standard with everything that we do, as we know, with the LARP principle as well. So the other thing I'll highlight is that these protection factors are based on the combination of the product. It's not purely based on I've got a chat box there. I'll see if there's a question, but it's not just purely based on the filtration. And I'm sure you've had it where I need a P3, and yes, a P3 is the highest filtration rating, but what is that P3 attached to? P3, 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 P3. So certainly whether it's half face, full face, negative pressure, positive pressure, continuous flow side of things. So in answer to your question, Claire, this is probably the poster I use the most, and I got created a number of years ago to try and help visually show what kind of combination of products has what RMPF or assigned protection factor. In the standard, it just has all text, which is helpful, but I can appreciate, it's people got to go, and because it hasn't changed since the 1980s, yeah, this is probably what I use as a visual guide, Claire, to help show the different levels and the hierarchy from a pure exposure reduction point of view.
Yeah, I was just thinking more from like, how you just explain the different types of protection factors as well, because obviously there is a lot of difference between the types of protection factors get assigned depending on the manufacturer and the air. Sorry about the noise. The entire company has just emerged.
They all want to
the
watch. They
workplace.
want to watch and learn as well. I'm fine with that. So, yeah, it can be overwhelming in that, but I think we've been not say conditioned or just we all work as I'm dealing with dust. I need a particulate filter. In the new ISO world, where the rating and classification will start with the protection class, which is the protection class based on the combination of the product. So I know one of the things for myself thinking about, I'll be doing a lot of training on these ISO standards in a couple of years, is trying to say, well, I like the fact it starts with protection level, to ask the question, well, what is the reduction in exposure that you need for what you're doing if you're working in this kind of work rate as well. So yeah. Kay Edwards, I haven't answered that question with some studies as well. Do we know? Kind of as well, but I'll keep moving on, being conscious of the time. So when we look at this exposure standard and the exposure standards being reduced, as we've seen, obviously with crystalline silica and the welding fume exposure. And so common question I get, I'm sure you've been asked as well. I've been using a full face respirator or a half face respirator with a P2, is that still suitable for me to use with the new exposure standard being reduced? So let me change this to a pen. I've got a couple of slides with silica and welding fume as well. So let's say your exposure is, we'll just use 2 as a nice kind of roundish number. So if we're at 2 milligrams under the old exposure standard, we're going to need something with this kind of amount of reduction. In the new exposure standard, current one, let's say we're roughly there. And then in the potential future one that'll likely come hit us. So as you can see that we've gone from something that, a couple of times over the exposure standard. So depending on what product is being used, or maybe we're at 0. No worries, Claire, catch you later. So maybe you're at 0.2, in here. And then they get higher and higher as well. But if it's still underneath a 10 times reduction, that combination, if it has an assigned protection factor, an RMPF of 10, very much could still be suitable. So it's not like a product hasn't changed, but it's based on those concepts of reduction. So same thing with a total welding fume, as we know, depending on what it is. What's your exposure? That's the first question I always ask. Is it still suitable? Maybe, maybe not. So same concept where maybe we were, 30 before, so we're 30, we're here, and then maybe we're, 30 here. So, it's going back and re-looking at what is the amount of reduction exposure I now need based on the new exposure standard and the combination of product. Do I need to look at something that has a higher RMPF? Maybe, maybe not. Depends on what that exposure is. Same concept works with gas and vapor cartridges as well. But the other thing is when we start getting our IDLH level. So once we hit IDLH, that's when we go from an air purifying respirator to jumping into a supplied air setup. Thinking about immediately dangerous to life and health, we have immediate consequences. So I'm only dealing with 200 ppm, hydrogen sulfide, but if we're over the IDLH level, we still have these cutoff levels where we go from air purifying. Not that you can't use supplied air underneath those levels, but certainly, if we do go over it, we need to go straight to a supplied air given the level of risk in that environment. Even if it's for a short period, we're still over that level. So, and then also with our standard, they talk about max ppm levels. I typically don't see that too much with people, saying, oh, I'm at 1,000 times over. So it'd be very specific gases, but there is sort of a cap on the amount of ppms in that regard. So one of the things Lucy and I'd spoken about is obviously with exposure standards reducing, a lot more questions from the hygiene world. Well, can we measure inside of a respirator to confirm that protection is at low level? So yes, this is our thank you for Mr. Peter Knott from the GCG crew. I was pinching his slide here from one of his presentations a little while ago, that yes, it is possible, but you've got to think about what are we actually trying to measure for? A workplace protective factor, an effective protection factor. Do you think if you're measuring, a PAPA in a head top, and every time they open it up, that's now an effective protection factor, because it's not purely the respirator by itself, as opposed to wear time or when you're taking it off, as well. So, yeah, obviously implications need to be aware of if you're looking to go down that path. Not something I personally have done. If I do get asked, I usually direct them to Mr. Peter Knott at GCG, or you can reach out to Hamish, who obviously works at GCG, to get their real world experience. Here's a couple of pictures I found delving through some of the older 3M presentations when I was sort of pulling this together to try and get some stuff of previous workplace protection factor studies measuring outside and inside. Here's another one here. I don't know if you're involved, Hamish, with the AWS one. So here's sort of ones that AWS funded and conducted by GCG, where they did a welding fume. Really interesting paper that they produced, and AWS has some really good resources about effective controls. And it wasn't just looking at, a PAPA effectiveness, but also looking on fume gun extraction, LEV systems as well. If I recall correctly, and please quote me, Hamish, but I think that, from this was an effective protection factor, about 2,500 times reduction, highlighting that these things are performing at a high level, even though we're still only using that 50 number as that selection as well. Australian, we've got the history as being fairly conservative, which is having a bit of conversation with the standards committee of late around that, or going to be as well.
Yeah, I wasn't involved, but Georgia, who is also on the line, did do all the sampling work for that. So
Georgia?
if anyone has questions, put them in the chat, and I'm sure Georgia can answer.
Anything to add, Georgia?
No, nothing to add there, but it's definitely a good read if anyone is interested in seeing how the PAPL systems work, as well as some other controls. Yeah.
I'd be just curious also, the challenges of thinking, this is obviously in a set up environment, but if you're trying to do this on the job where people are climbing and doing all kinds of stuff, the implications or the factors would play into, the measurements and all that kind of stuff as well. So, no, awesome. And here's an ozone one that they did with Work Sciences. So they've recently published, not quite as detailed as the GCG one. No surprises there, GCG crew. But they did some also stuff with ozone, which was interesting. Facial hair, as we talk about, you mentioned there, Kay Edwards, not sure your first name there. Certainly plenty of historical papers showing that in the presence of facial hair, there is significant levels of reduction of expected levels of protection. So on these particular ones from the 1980s, leakage goes from 20 to 1,000 times, and facial hair is going to be different in how much, but just showing it's about the predictability and reliability of that protection being achieved. You got one as a 330-fold drop in protection. HSC have a really good paper, research paper that they did. I use all the time in my longer presentation. I usually show where they had, I think like 10 workers or 10 people, and they were fit testing them every single day as their facial hair grew on 4 different respirators each. And they've got some really good visual guides I use, and free and happy to share those kind of ones. Actually, if you go to the ResFit, that link there, they've actually got links to that HSC paper there. We're showing, maybe on day 6, this work on brand X was getting, a pretty good level of, protection from an inward leakage point of view, but on the same day with brand Y, they get a much bigger increase in leakage in that regard. So it's that predictability and the reliability side of things, which is why bringing it back to, being clean shaven aspect is what we can kind of, bring it back to from an individual point of view. So, and it's not that you get 0 with facial hair, but thinking about these assigned protection factors or RMPFs are based on doing all the right things at an absolute minimum. Like I usually in some of my other presentations, and it shows, like, I think it was like 4 papers, a group of 4 cohorts are showing this plot graph where out of the cohort that were not fit tested, similar but different with the facial hair, but even just with the fit testing, that 50% achieve the assigned protection factor above versus the 98% of the cohort, the 13 studies that were fit tested. So we're just increasing our confidence, our probability of that protection is absolutely going to be achieved. I know this sort of a 3M sort of slide I use, talking about facial hair and what types of respirators may or may not be compatible with the facial hair in question. Clean shaven is going to give us the green ticks across the board, as we're thinking about that facial hair interfering with the sealing surface area. So looking at a full face there, we're looking at the outside sealing area. The orinasal section on the inside isn't creating that respiratory seal. It's about directing that exhaled breath out of the respirator from CO2 point of view. So hence why we've got a green tick, even with the mustache, as long as it's not interfering on that outside there. Reason for the question mark is the 3M position. And this is where you can get, I guess, different positions or what different manufacturers will put out there based on where they end up with how their claims and supporting what they put out there. So even with the 3M products, the concept is that the seal area is still not to be going on the facial hair. It is to be surrounding the hair, because even though it's a positive pressure head top, it is still not a magic bubble. You can still get an increased amount of leakage of air, even though it's positive pressure going out when you think about the type of bushy beards there are as well. This particular helmet hood one in the M400 and some of our S series ones, the sealing area is actually much lower down around the neck. So the, if you've got a longer beard or facial hair, it's about making sure you can tuck it up to be inside that sealing surface area as well. So like this is a quick whiz, but it's going to be that assessment of the individual. If you've got someone who's growing their facial hair for, Santa season, maybe there's nothing that's going to be compatible with them as well. So, yeah, so that's sort of, I think I touched on everything in Lucy, but certainly if you scan that particular one with your phone, that should save up my contact details in your phone, should pop up there as well. But and I think we had one question from Antoine about shelf life of respirators. So is that more the filter or the product itself? If you're able to jump on the mic or chat and put in the chat.
Yeah, g'day, Mark. It's more, the actual face piece. I've had some discussions with people we provided with the AdFlow PAPR and the welding PAPR as well. And I guess part of the business, they've noticed that some of them have a stamped shelf life on them. And so they're just wondering whether they should, automatically just replace the respirator and buy new ones. So yeah, from what my understanding and what I've been telling them, it really depends on the usage, the maintenance program, and all that kind of stuff. Because obviously we're gonna have some people that gonna have like an expensive, PAPR for welding. They might use it twice a year, and if we have to buy them new ones every couple of years or so, because sometimes we buy them and it's been sitting on the shelf at the provider for like 2 or 3 years. So you buy them and they only have 1 or 2 years left on the shelf life stamp. But just wanted to confirm that with you, I guess, just to really, the shelf life is kind of like indicative, and it really depends on the usage, the exposure you have, the contaminants you're dealing with, and making sure we're implementing that maintenance program and repairing and fixing things as they deteriorate, I guess.
So we can split it up. So you got the filter side of things. So the filters definitely will have a date. From a, let's say, reusable respirator face piece point of view. So I know with the European standard, where most of our stuff that we get in Australia comes through our European supply chain, we'll have a 5-year shelf life date on the face piece, but that is purely sitting on the shelf, not being used. Once it is opened and in use, it will purely come down to the care and maintenance of the product in question, which you kind of alluded to, where seen many products that are looked after very well and get years and years and years out of it, and some that are not looked after very well and they're lucky to get 3 months out of it. So really, once it's open, it does come down to how's this being looked after, which is clearly out of the the control of any manufacturer once it's open. Certainly with PAPR units, being conscious if it's being used twice a year or infrequently is that battery. If that battery charge goes down, it'll go into brick mode. The other side of things is thinking about depending on the head top. So this is a hard hat rated product. So certainly we've got a hard hat standards which suggest a 3-year date because of the shell. Now, obviously, these are a fair bit more costly, from a cost point of view than a standard hard hat. So no 3M will say, at absolute maximum 5 years type of thing, giving, that it's intended to perform in that certain way as well. So it will generally, once in use, come down to your care and maintenance and where it's being used and those kind of things. So I think you're spot on the right path as well. If we're looking after it, absolutely. If not, might be a little bit shorter and cost the business a fair bit more. You're having to replace things more often. If that kind of hopefully answers the question.
Yeah, great. Thanks, Mark. Yeah, just good to hear that you're validating my train of thoughts. And I thought the shelf life was more for the sellers, I guess, so that they can't just stock them for 10 years and then sell them. So yeah, no, thanks for clarifying that for me.
Sorry, it's fun. I know with some of the NIOSH products that come through the US, NIOSH don't have a set shelf life date, so they will. And over the three, I had a global letter come through because I had someone asking about this as a common question, and sort of saying in the US, well, as long as it visually still looks all good, even if it is 10 years old, I certainly probably wouldn't be super comfortable with 10 years, but maybe you replace a few components, so they sort of go off the visually, does it still look okay and will function, the other kind of checks as well. So different global kind of things, but typically would be saying the 5 years sitting on a shelf as the manufacturer or the distributor manufacturer date.
Yeah, awesome. Thanks, Mark.
No problem. I see a question there from Bridget. Is that gonna mention there, Lucy? You got a question there from Bridget?
Oh no, go for it, Mark. We'll just keep the questions rolling in. We've hit the hour, but if you're happy to stay on.
I'm excited I get about respiratory protection. I'm gonna take my jumper off. Oh my gosh. Fit testing and PAPRs. Well. So easiest way is, what is the head top or what is the face piece being used? If it's a tight fitting face piece, whether it's positive pressure or negative pressure, air purifying supplied air, then that, yes, still needs to be fit tested based on it being a tight fitting product. If it's a loose fitting head top on supplied air or maybe a PAPR, then no, that does not require fit testing as well. So it still does depend on what is the head top. As opposed to, certainly, I think we've improved. When I say improved, general, it's a PAPR, I don't need to be fit tested. Well, yeah, but what is the PAPR connected to and going on the wearer's face? So when we look at, let's say, an SCBA where it's tight fitting and positive pressure, it has the highest, the higher RMPF levels, because it's what's going to be recommended for use in ideal H environments, being oxygen deficient environments, and that's based on getting a fit as well as getting the positive pressure. So just because it's positive pressure tight fitting, you can still overbreathe that. And I've got some other slides that'll show that'll dip into negative pressure at those high work rates or high breathing rates. It doesn't mean you're going to get zero protection if you've still got an appropriate seal, to fall back on as far as that there being there as well. So given we are talking about PPE, respirators, and still human compatibility and human behavior as well. Oh, Bridget, you're asking the controversial questions here. So personally, yes, I would classify a clean space, half face, and a full face as a tight fitting. Certainly very aware of some of their sort of their position as far as they believe it should treated as a loose fitting product. In Europe, as an example, they have, and I guess this sort of goes to the age of our standards, where in Europe they have what they call TH and TM classification for their PAPR combinations. TM is mask, tight fitting, and TH is H for hoods. So in Europe, the clean space, from everything that I can see and looked into, because this is a common question, for me, is that is classed as a TM in Europe. So yeah, I mean, but then I appreciate working for a manufacturer that if you're intending it and conform, then you should be able to class it. I guess it's sort of that mid classification. One of the things where I'm looking forward to for the ISO standards in the future is that products will be, as part of their rating, will be classed as a T or an L. So it'll be an AT or BT or CT with a number, the letter referring to where the sealing area is. So if a manufacturer like Clean Space want to, have their product treated as a loose fitting product, then they absolutely, and anyone could, have it tested as a L type product. And this sort of also goes back to, I guess, not to talk specifically about Clean Space, but certainly I know they put a few white papers out there about the facial hair on their products as well. And I sort of obviously highlighted 3M's position as well. So certainly different manufacturers, based on, I'll talk from the 3M point of view, liability point of view, very, very conscious. So certainly each manufacturer will, put stuff out, to back what they want to say for people how to use their use their product. So we do get a bit of a grey area. I certainly know of another manufacturer in their particular product where they've gone external, third party, test lab testing with facial hair, all different various levels, not done by themselves, to the ISO standard TIL testing criteria as their evidence. And I look at them and go, it's pretty good as far as the evidence to support that, that would still be performing at X level with facial hair with their specific product. So I think, facial hair from a standards point of view, I can't see it ever sort of being in there as an acceptable thing, because there's so much variability between people and products and how products work to make a blanket statement that, even like looking at the beard wrap technique is another one that sort of comes up. That's not that you can't get a fit, but certainly that predictability and the reliability side of things. I know Royal Melbourne Hospital in the healthcare space are doing some amazing stuff as far as validating and supporting in their world the use of bead wrap technique. Now, it's not something that 3M recommends or ResFit recommends, but for their world, they're building that data to support, their risk approach to do that. But they're doing 2-hour fit test sessions. You have to do like 6 or 7 passing fit tests on multiple products in that 2 hours. You get fit tested, I think 6 monthly and 12 monthly, but really it's that repeatability of donning the standardized their TheraBands and the process, so they're doing some, interesting things. I know from an ISO committee level involved with as well, like it's not that it can't be in a standard, but to make that blanket recommendation for all workplaces and all workers is big and hard, to have that kind of confidence as well. So you can imagine I'm sure many of your work sites being more of the industrial spaces thing, or where you can you imagine a construction worker or a tunnel worker wanting to put a beard wrap technique on and doing it properly every single time, or would you have your business have the resources or to go down that journey of, hey, yeah, we're going to do 2-hour fit test sessions and fit test people 3 times a year type of approach. So that's where I personally think it'll come down to, workplaces and how they want to control, their variables. Obviously what they're doing in the hospital is specific to the hospital and bioaerosols and stuff, versus would that be suitable in other environments. So you may have seen, I know AOH, if you're an accredited fit tester, and I put up on LinkedIn, I'm hoping for Alicia to share it out to all AOH members, is a ResFit, position statement on non-compliant practices, which does include bead wrap and fit testing and positive pressure as well. So we're trying to, from a ResFit point of view, to put where we want to draw a line in the sand to help fit testers and educate workplaces, then, getting advice or guidance that kind of go, oh, I'm not too sure, and running with that. So key part of what I try and do in the respiratory protection space of things. So hopefully I haven't waffled on too much. A few people stuck around, so hopefully I haven't keeping you too much from your day.
No, thank you, Mark. Does anyone else have any questions before we finish up?
I can waffle for hours, so it's always a challenge.
Feel free to put them in the chat or speak up. But no, thank you so much, Mark. It's really good to have all of that information. Just as an example, I had someone I was fit testing the other day on site, and he had the stubble, and I was trying to say, look, I don't want to fit test you with the stubble because these are XY factors. We don't know what your beard will always be like. He kind of mentioned the odor threshold, and he said, oh, well, it's fine. I can't taste any dust. And if I do, he said, I'll lick my finger and wet the seal of the mask, and then it always tends to go away because it's stuck to my face. And so I think it's good to have some of this context where we can go, well, actually, it doesn't work.
Predictability, reliability. It's not rolling a dice. And sometimes it's going to land on, yes, I get a fit today, versus confidence each and every time. I use a silly analogy to keep me waffling on while I bring up something else I just thought you guys would find interesting that happened 2 days ago, was, like going to the gym, or, like we don't base it off going to the gym once, if you know what I mean. Like you go to the once, like, do you look any bigger or buff? That's crap. I went once and it doesn't do anything. The same thing goes for PPE and fit in that report. It's not, wearing it correctly once you know, if it's that, you know, day in and day out, or 80%, 90% of the time. And yeah, we're going to have those times maybe that we're not getting the fit or lower protection, but we want that to be in the vast minority as opposed to the majority of the time. We've got confidence that fit is being there, as opposed to we're wearing it correctly once out of 10 times. It's a silly little analogy,
or just once a year when you do a fit test.
Or once a year when you do a fit test.
There's one more question in there from Antoine about what's your take on the 30-day respirator use trigger for health monitoring in the new silica code of practice?
I'm not across that. I haven't needed to delve that deep, so I might have to look into that. So what is it, if you're wearing a respirator for more than 30 days to protect yourself from silica, that triggers?
Yeah, I should have mentioned this is the new Queensland code, well, not so new anymore, code of practice, but essentially in the code of practice, it says that if you have to wear a respirator to protect yourself from a silica hazard, and you have to wear a respirator for more than 30 days in a 12-month year, then you have to undergo health monitoring, which I don't know, not really sold on it.
To put a line in the sand. I mean, this is just my off the top kind of thoughts, you know.
Yeah, I think the unions and stuff had to do something with that. But my main worry is how they're gonna, keep the register up. How we're gonna make sure that, there's a lot of grey areas. So I was just if you had any opinion, but you might not be too across.
I guess I'm probably thinking, having dealt with a little bit more with regulators these days, that it gives them something to refer back to, to say, well, as a workplace, where's your record that it isn't, if you can't demonstrate, kind of thing, whether it's 30 or 20, but that's probably something to help them to be able to, get workplaces referred back as a line in the sand type of thing. Intro, I'll have to look a bit more at that, but thank you for sharing that. Something I just thought you'd find interesting with the few that are still left here. So this is an absolute complete fake fit test report that ResFit got emailed from a university where they had a health student submit it as their evidence that they'd been fit tested. So don't want to put Hamish on the spot, but how many red flags can you see with this fit test report? Do you normally check on normal lung size when you're doing a fit test?
Can't say that would be within my realm of expertise to comment on, to be honest.
Alongside bread, it's just, this is a complete doctored, Connect training don't do fit testing as a service, so that's sort of off the thing. KC, Kimberly Clark, just crazy, just so doctored and stuff like that. So, we've done both qualitative and quantitative as well. So I know some of the guys in Sydney, the hygienist on the tunneling sites, contractors submitting stuff, seeing a lot more fake or doctored fit test reports. I don't know if those are doing fit testing in your organisations have seen many of those. I know Michael Lever and their crew have seen people using their kind of doctored ones and changing numbers and dates and stuff like that as well. So this 2 days ago, ResFit was emailed asking, so we don't do fit testing. Let me reach out to Steph at Connect Training, and came back very quickly and went 1000% fake. I mean, a Breathe Easy just got discontinued about 15 years ago. So that stands out to me, knowing that bit of information. But
Yes, so, interesting.
Which is something that workplaces, regulators are knowing the fit testing. So this is kind of should have been an expected byproduct when fit testing is now part of the conversation, the requests that, some percentage of people are going to try and cut corners and do what they're going to do. But anyway.
I think Georgia, are you still on the line, or did she jump off?
She just left. I just sent her a I just sent her an internal Teams message saying, "You're up. You got a question." I can try and answer it for you if you want, Bridget.
I was trying to find the study. It was the AWS study.
Correct.
And
yeah.
There was just one kind of anomaly that I think it was the PAPR's we're getting readings of I'm not sure if it was welding fume inside, and it just seemed really odd.
I mean, there's a few things to consider, right? you're talking about, again, it's a hood type respirator. So if they had, we weren't specifically measuring for like welding fume inside, but it was using ultra low detection limit metals analysis. So if you've got any kind of metals that are coming off like clothing, or if you had any residual fume or anything on his face or something like that, then you potentially get some kind of impact from that.
Yep.
But yeah,
Even just
the
keeping it
idea,
on and off in a contaminated space.
yeah,
Yep.
yeah, exactly. So like that, it's entirely likely that between sets that PAPR might have been taken off, or there's some residual particles somewhere that have made their way inside.
Yep.
I know for when I've asked some of the 3M people and previous people, you know, with the monitoring is with the sampling is decided how much is skin generated as opposed to contaminant generated. So there are those kind of factors that come into what are we actually capturing and measuring, and trying to isolate what is that specific reduction from a respiratory protection exposure point of view.
Yeah, but I mean, like Mark had in his slide, we typically try to steer people away from doing those kinds of studies, just because no matter how thoroughly you do it, it's still a point in time. It's in ideal conditions. It's an interesting one to try and hang your hat on and say this is exactly how well it's protecting everyone all the time.
Yeah, that makes sense. Just an interesting thing to mention.
And then when you get
completely unrelated but related, I tested someone, I think it was last year. He had a P3 respirator that expired in 2004. It still passed.
Yeah, if it's was it a disposable or reusable?
Reusable.
It's not too surprising given.
Yeah.
You know, that all the other parts of the disposable comes into it. You know, that the filters are going to perform. It's a liability from a manufacturer. You know, we're not going to say, "Oh, this thing lasts forever," and we guarantee it's going to be at X level.
I tested it out of curiosity and then told him to get a new one.
I'll show just because a few of us here, but this is talking about real world exposures. So one of the things that I guess I'm seeing more of is as these sites, you know, across the country in various industries are more going to PAPA, it's the challenge is the caring, store and maintenance. You know, it's not so much when it's in use. And so the care and maintenance, we're seeing way too many of these kind of things when they're changing it or it's being left out to see how much gets behind where the filter is and actually gets into the blower as well. So I've got pictures galore and I've pulled a couple apart. You can see the amount of dust, you know, that's gone in and been getting pushed out and how much is in there. So, you know, as much as we go, reduction, often, you know, it's all this stuff is going to contribute more to often their exposures than, you know, when appropriately used. And I see way too many of poor, you know, care and maintenance conditions with, I remember that one, that was about 2 weeks ago. I turned it on, got it working and a dust cloud puffed up out of it. You know, these batteries back and they're like, oh, we want to claim it under warranty. I was like, that's a care. Where are you storing? What are you doing? You know, coming back fully corroded and stuff like that. So, you know, and this was, you know, the inside of a head top. Inside. So, you know, the outside, like that's the environment many workers work in. So it's not so much.
I have to say that looks like a tunneling workplace.
Yeah, these are all ones that we do a lot of work with, and just to highlight the environments. And you know, they've made so these are the examples of some of their sites that I sort of use as examples. You know, I was out of the mine last week. What are other places doing? So we sort of show this is the kind of stuff that they've set up for them, where they've got tubs per person, per shift, a full-time person cleaning, maintaining, you know, changing things out. But even saying that, it still comes down to attention to detail. Here's one of the other ones where they've got sort of people and areas. And this is sort of their charging bay area. When you look at if that's their volume that's their scope of project, that's the infrastructure you need to support the equipment. So there's a few others sort of just to highlight, you know. We do have new charging cradles coming out, hopefully for the next 12 months that will daisy chain together to try and avoid this kind of spaghetti junction kind of mass site type of thing. So they're all the things that in my role, you know, when Global reach out and go, do you think your customers would like a 10 base plate charging cradle. And I go, yes, absolutely. And so I share all these kind of pictures with our global teams to, you know, when we're trying, we want a thing, you know, and obviously we go into the bucket with all the other countries, but you know, having real world evidence of how they're being used, you know, goes a long way to, you know, internally. So this is sort of a couple of setups that, you know, 5 or 6 of the different tunnel sites as well. So so your question about, yeah, stuff getting on the inside when yeah, when you look at that kind of head top on the inside, not too surprising in real world. So yeah, one of the things we're doing a bit of work with, I've got my things is, I've lost it. What have I done? I need it for my next training session, but like getting, you know, really talking more about storage plugs. So when the blowy units are not in use, you know, you put a storage plug on there just to block the opening as well. Where is it? I lost it. It was here a second ago. Oh, it was behind you. So there we go. Or having a breathing tube plug. So when the breathing tube's taken off, that you can actually block up the breathing tube and then connect it up to close off the loop, you know. So they're the kind of things, seeing these kind of sites and the mass usage, which is fantastic on one hand, but you still got to care and think about the when not in use environment. So that's why I spend more time talking about that and these kind of things that need to fit into whatever's going to make sense for that stuff. So it's yeah, interesting.
Cool. Well, thank you so much, Mark. That was really good.
I had a good time. I love talking this kind of stuff.
Yeah.
It's way more interesting than half the inquiries
thank you,
I usually
Mark.
get.
Much appreciated.
Yeah. It's great to have that background information, really is, because we spend a lot of time, you know, dishing out respiratory protection, but probably not knowing enough about it ourselves. So
this is the fun and the challenge of in hygiene. There's so many areas that you'll never know depths about, you know. So I love what you guys are doing with the EHG group, is connect with different people and build your connections. So yeah, so when I've got questions on Hogwarts train Lego, I ring Hamish. It's all about who you know.
You'd be surprised how often that happens. Yeah,
it does.
It is more often than 0 times.
It's always my question. I'm like, come on, you got to build it, dude. What's going on?
Yeah.
Yes.
Well, I better run. But thank you so much, Mark, and I'll catch you soon.
Sounds good. See you.
Good. See ya. Bye.